everyone. In this chapter, we'll continue our discussion on wireless LANs. So first, we'll start with an example of the TJX bridge, and then we'll introduce on what wireless security is and why it is so important. And then we'll talk about specific standard 802.11i, which is for LAN security. And then we will talk about how it works and why it is not enough, and how it can work with other standards. And then we'll also talk about Wi-Fi wireless LAN management. And then we'll talk about how we can measure the strength of Wi-Fi signals and the unit, which is decibels. And then we'll also talk about some other related technology like Bluetooth and also other local wireless technologies. TJX is a department store chain in the US. So in this incident, the hackers actually broke into a TJ Maxx store in Florida through a weakly protected access point. So it's just through one of the wireless access points. Right? So TJX is the parent company of TJ Maxx and other stores, which are quite popular in the US. So and then, just through the wireless access point, they find that the hackers actually were able to go into the company system, and then the company were actually leaking a lot of information to these hackers. So some of the characteristics here is, in this case, the hackers, as I said, just broke through the wireless network. So a lot of times people thought wireless network, like a wireless access point there, it's just for people to access their Wi-Fi, access the Wi-Fi and access the internet. It would not be very harmful if people just get the access. Right? Actually, it's not true. If people got the access, they might be able to do a lot of things, right? They might be able to listen to your traffic, and even worse, they might be able to break into your system. Yeah. So firewall protection and encryption are important, and they didn't do well in this case in TJX. They didn't have the firewall for their access point. They did not encrypt their data on the wireless, on the Wi-Fi. So that's why they got again the hackers were able to get the information, and in this case actually they leak out some of the customers' credit card information through this breach. So that's why it's actually important for company not only to protect the wired network, but also the wireless network. So in this case, the hackers download the millions of credit card numbers and related information of their customers. So of course, this kind of breach is extremely time sensitive because you need to be able to stop all the hacking immediately, and also inform all the customers about their credit card number loss. And these cases are also very expensive to handle because you may need to pay the damages to the customer. In this case, the thieves actually were loose international group. And so they actually work together loosely but internationally. So that's why it's very important to protect your endpoints. So wherever you have a wireless access point, it is one of your endpoints. Right? If people could break into your system through this endpoint, then it's like you have a serious threat to your company. So to deal with this credit card threat, company actually came up with this PCI DSS, which is the Payment Card Industry Data Security Standard. So they come up with a set of guidelines or requirements that companies should follow when they handle credit cards. For example, they need to build and maintain a secure network, install and maintain a firewall configuration to protect cardholder data. Do not use vendor-supplied defaults for system passwords and other security parameters. So of course, don't use the default passwords. Protect the cardholder data. Protect your stored data, and also wherever you transmit your credit card data, you must encrypt the transmission. Right? When you transmit, especially across open and public networks like Wi-Fi, right? Or even the internet. Right, so when you we need to maintain a vulnerability management program. That means companies should use and regularly update antivirus software on all systems commonly affected by malware. Also develop and maintain security systems and applications. Also implement strong access control measures like restricting access to cardholder data by business need to know. So only who need to know the data should have access. Other people should be denied even if they are your employees. Assign a unique ID to each person with computer access. So for each of your employee, they should have an ID so we know who is accessing what data. Restrict physical access to cardholder data. So again, physical access should not be granted easy server. All this data on the database server, then the database server should be locked in the server room. Also regularly monitor and test networks. So companies should track and monitor all access to network resources and cardholder data. Also regularly test security systems and processes. Also maintain an information security policy. So companies should maintain a policy that addresses information security. So we'll give a brief introduction of what this wireless security is and why it is important. So companies basically face two classes of external hackers. The first type is what we call the wall drivers. Second is really drive-by hackers. The wall drivers actually are people who try to look outside your building, or people maybe like going to the university campus and try to test out your networks. Right? So these people actually collect access point data, your SSID, the strength of signal, the security level. So because all these are public information, right? Your Wi-Fi access point will be broadcasting these signals to all the devices. So actually, people can collect all this easily, right? SSID is basically your network name, right? And the string and so on. And they may be publicizing your findings, and they normally do not read your messages, right? They do not send a text. They just need to find out. They basically just look at your public information that you are broadcasting, and then they collect information, and then they may publish it. So of course, this kind of behavior is considered legal, right? Because again, all these are information that are open for collection. But then the other type is what we call the drive-by hackers. So again, they may be outside your office buildings, or they may be on your campus. They also collect all this information regarding your network, but at the same time, they may also try to read your messages. Again, because of the nature of Wi-Fi, a lot of times people may not be encrypting their data. Right? So they may be able to read your messages, and then they may be sending attacks that bypass the firewall. Right? So they may try to attack your network, um, try different passwords using a brute force method and so on. So of course, these kind of activities are normally considered illegal. Now we'll talk about how we can deal with all these possible attacks through 802.11i LAN security. So 802.11i actually have the cryptographic protection. So like normally when you transmit a message, like you have this wireless client, so maybe your laptop or your phone, and this one is your wireless access point. So it could be your just the access point or your wireless router, and then the wireless access point normally is connect to the network, right, through wired, right. So this part is not the scope of 802.11i, right. This part is the Ethernet, right? So then during your wireless transmission, then there may be some eavesdropper, like someone who is trying to listen to your traffic. So the drive-by hacker. So this is the part where the 802.11i protection will be involved. So you do the initial authentication, that means to verify who you are. And then you will also do the message by message CIA. So the CIA actually is the confidentiality, integrity, and authentication. So confidentiality means it is your message is secret, other people cannot read your message. So that's the confidentiality. Integrity means your message has not been changed by others. So there is a mechanism to make sure that your message has not been changed. Like even though no one is reading it, but with some checksum that we can find it actually has not been changed by others. And authentication is you still make sure you are communicating with the person that is supposed to be communicating with you. So that's the C, I, and A for the message. And 802.11i actually will provide this message by message level CIA, which we'll talk more about later. So of course, as we look at the previous diagram, like 802.19 protection is really between the client and the wireless access point. So there is no end-to-end encryption protection from the client to the server. Right? So the encryption is only done here. So you encrypt the data and then send it to the access point, and then it will be decrypted at the access point. So if there is a hacker who have access to your access point, who can hack into your access point, that this hacker would be possibly getting your data. And also this part will also from the access point to the server, the wired part also need protection. Otherwise, you only protect this one part. So 802.11i provides security between the wireless host and the wireless access point. So it has limited group scope, but it protects quite well for this defined the scope. Right. So it uses a strong cryptographic standard, including AES for encryption for confidentiality. So we are not going to talk about cryptography in detail in this class, but basically AES is one of the good standard for encryption. So it uses strong standards for also all other aspects of cryptology, or sometimes it's like cryptography. So basically the standards that are defined in 802.19 are good, and it is actually providing good protection between the wireless access point and the wireless host if you are doing it correctly. So since the beginning of Wi-Fi, then there were actually many different standards for wireless security for Wi-Fi. So the very first one was the WEP. It's called the Wide Equivalent Privacy. So it was kind of in the beginning of Wi-Fi, and then it was not created by security experts. So it was created by some more or less the network and technical people, but somehow these people were not security experts, and then there were a lot of problems. So it was supposed to be deeply flawed. So that's why it was used in the beginning, but people basically don't use it anymore. And then later on, then people came up with the WPA, which is which stands for Wireless Protected Access. So it's the early draft of 802.11i, so it's better than WEP, but it's still using much weaker standards. So nowadays we should be using WPA2, which is based on the 802.11i standard and provides much stronger protection. So when you configure an access point, so you need to select your 802.11i or WPA2. So some of you might have that experience when you buy a wireless router, then you set it up at home, right? Then the first time you set up, then it may ask you to select the security standard, or sometimes when you go to the admin panel of your wireless access point, then you will be able to select this. So make sure you select WPA2. Do not select WPA or even WEP, right? Because WPA is like, as we say, is the weaker standard. And never select WEP, which is an earlier standard created by the 802.11 working group, but it's for the again, it was set up by those networking people, but not the security experts. So these are these earlier standards like WEP and WPA actually do not provide acceptable acceptable security nowadays. So for the AO2.11i, actually there are two major modes of operation. So if you are saying setting up at home or business with a single access point, then you use a simple PSK mode, pre-shared key mode. So you don't have a central authentication server, and then the authentication is basically the knowledge of a pre-shared key. That means for the wireless access point, you always use the same key. Again, just like when you are setting a wireless access point at home, you basically use the same password for all the different devices, for your phone, your laptop, and your parents' phones. Then you should share the same password. Then this one is called the PSK, pre-shared key. And technical security is actually quite strong already because of the cryptography used and other standards used, but the human security, of course, is more vulnerable because in this case you can share your passwords quite easily. Where some of your friends are visiting your home, then you may share the password with them, right? And also you may, a lot of times people may just write the password and then stick it somewhere, especially like even if you go to some cafe, they will share the password with people easily. Go to some restaurants, they will just write their network name and password on the wall, right? So basically the password might be shared quite easily with others. And there is a better mode which is based on the AO2.1x mode. So usually this is for companies with multiple access points. So again, like a company, then you might have multiple access points across several stories of a building, or like on the university campus, you might have many access points. Then in these cases, then you use a central authentication server. So normally for the single access point, the authentication is just done on the wireless access point or done on that wireless router, right? But then in this case, you have a separate central authentication server. Just like when you go to Hong Kong, you log into the HKU Wi-Fi, then your authentication will be done through your portal username and password. That one is actually done through a central authentication server. And then your credentials are also stored on that authentication server. Again, like your Hong Kong U portal username and password, they are stored separately. So in these cases, then the technical security and human security are both very strong. This diagram shows how the PSK mode works in the AO2.11i. So as we said, there is a pre-shared key shared by all users. So then in the authentication stage, that means when you first connect yourself to the Wi-Fi, to this particular network, then all PCs will have the same key, right? The same key for X, Y, and Z, and you will send the key to the wireless access point when you log in, and if it matches with the password record on the access point, then you will be allowed to connect to this network. So this is the authentication. So it's not individual authentication, but at least we know you are allowed to use this Wi-Fi. And then when after you have logged in, then we need to have a separate key for the message protection, right? So in this case, then the access point will give the host an unshared session key. So in this case, we call it AX, right? So it's a key for host X. So we just call it AX. So this key is not shared with other hosts, and it will encrypt messages with AX for all the messages between A and X, right? So that's why even if Y is also connected to the access point, but it will get a separate key, and it will not know the key AX and will not be able to decrypt the message of AX by other hosts. So someone actually might give the password to unauthorized people, as we said, like for this kind of like shared password setting. People think is actually not a big deal to give a password to others because so many people know already. So we need to be careful about this. This is one of the security threats in this PSK mode. Also, the shared keys are generated usually from passphrases. Now, of course, if we want to do it better, then the passphrases should be as long as possible. So it has to be at least 20 characters long. But of course, in practice, very people will set a passphrase that is so long. So if you of course when your passkey phrase is not long enough, then people are easier to hack it. Then there's actually another related process called the wireless protected setup. So this one is actually a link to show what it is, but don't listen to that guy because it is actually very insecure. So this WPS was created by the Wi-Fi Alliance to make the PSK setup easier. So in some cases there is actually a button on the your wireless access point, and then you press that button and then you can set this up. But actually in that case also the user can enter 8-digit pin for a particular access point. But unfortunately, people find that this standard again is can be cracked very easily and should be turned off on the access point if possible. So if you see there is an option to turn this off, remember to turn this off. Actually, people find that this WPS is very insecure. And again, like now we know for a lot of security standards that were proposed by the Wi-Fi Alliance, they actually were not that secure. Because again, these are not security experts. So now let's look at 802.11i in the 802.1x mode. Remember we talked about 802.1x authentication for Ethernet in chapter 5, right? So normally when you have this central authentication server, right, and then this one is a switch, and then you have this connection. This one is your LAN cable, right, on Ethernet, and this one is the wire supplicant, your host that tries to log in, right? So remember we talked about this. So 802.1x, then we have the port-based access control, right? So just a recap of what we did earlier in chapter 5. So when we have 802.11i and 802.1x together, it might work like this. Right, so here is your wireless access point, and then you have this Ethernet switch, which is not an authenticator because like you have the central authentication server here, right? So you have multiple switches that may be authorized through the same server. And then if it is based on 802.1x, the Ethernet, they just work at the same as before. You have the port-based authentication. And then if it's an access point, then actually it's quite similar. Then you still have to log in through the central authentication server. Right? So that means you first connect to the wireless access point through 802.11i, right? So just like the one that we just mentioned. But then in addition, then there is also this central authentication that you have to go through. So 802.1x requires a confidential client authenticator link. So it's not a problem for UTP, but it's actually a big problem with wireless connection, right? Because when you look at this part for the connection for 802.1x, there is no need for additional protection, right? Because it's wired. You suppose like the wired part is already protected, like people would not be able to go into your wall and then cut into a wire to get the signal. But then for wireless connection, that of course this part, as we said, we need additional protection here. Because the wire signal actually is kind of broadcasted, people can intercept easily. So the solution here is actually we have the SSL TLS, where L2.1i and L2.1x that kind of have to work together. So we create an SSL TLS connection between the access point or authenticator and the client. So SSL is the secure socket layer that we talked about earlier. Right? So this will protect the confidentiality of the subsequent 802.1x message exchanges. And also the most popular standard for using SSL TLS with 802.1x is the PEAP standard, PEAP. So we are not going to go into detail of this, but if you are interested, you can look for more information online later. Next, we will talk about what we need to do in addition to 802.11i. So you just using 802.11i is actually not enough. It only protects you from some threats, but not all the possible threats. So there are other threats which must also be addressed, like rogue access points and also evil twin access points. So the rogue access point actually is a problem with like particular kind of failed access point. So normally if all your access points are good, they are secure, they are installed with the latest updates and patches, then your drive-by hacker actually will not be able to hack into your network. But then if you have an unsecure, sometimes you call it the rogue access point, then you just need to have one failed access point. Right? If you have one access point that is not updated or that have some security issues, then the drive-by hacker could then get into your network through this rogue access point. Yeah, so we need to be careful. All your access points are secure. So just a quick question: is it a defense in depth problem or weakest link problem? In this case, this rogue access point, of course, is the weakest link in your network. Once your weakest link is broken, then people can get access to your network. Another problem is what we call the evil twin access point operation. So in this case, an attacker computer actually impersonates an access point. So then it tries to open connections to the client and access point separately. So it's a classic man in the middle attack. So that's how some people call it. So the idea is that sometimes when you go to a says cafe, like you go to Starbucks and then you just want to log in the Starbucks Wi-Fi, and then you see a network called Starbucks, right? And then you just log in there, and then when you do that, actually that network name that you see with Starbucks may not be the actual like the real Starbucks Wi-Fi. It actually might be the hacker's Wi-Fi, right? The hackers set up a fake access point for that. Then in that case, then you'll be able to get your login credentials, right? Because you are trying to log in, right? So you will get your credentials, and then this evil access point will pass your credentials to your legitimate access point. Then if that is successful, they will be able to intercept all the messages that you exchange between the client and also the access point. Now we'll look into more detail how this evil twin works. So suppose you are the victim client, so the victim will encrypt the message with a key 1 shared by the evil twin and the victim. And then it will send a message to the evil twin access point, thinking that it is a legitimate access point. And then the evil twin actually can decrypt your message with key 1 and then reads your message, because this key actually is created by the evil twin, is shared between the client and then the evil twin. So the evil twin knows the key. And at the same time, the evil twin will decrypt your message with key 1, read it, and then re-encrypt it using key 2. Right, key 2 is actually the key shared by the evil twin access point and also the legitimate access point. So you re-encrypt the message using this key 2 and then send it to the access point. So that's why the access point would also think this one is a legitimate message. So in this case, the evil twin will be able to read all the messages between the victim and the legitimate access point. So in order to address this issue, the client actually will need to have a VPN connection with the server. So VPN is a virtual private network. So VPN encryption uses a key that is never transmitted, and so it cannot be intercepted by the evil twin, because the um this VPN connection, actually you need to have a key, right? And this key is actually not shared over the connection, right? It should be kind of pre-shared before, right? If you have the VPN, you should have already set up a password using a separate channel before this, right? So that's why if you are using the VPN, then this password for the VPN or this key is never transmitted here, then the evil twin would not be able to break it. So without a VPN, the client will encrypt with the key it shares with the evil twin, and the evil twin can decrypt the message and read it, as we already described. Then the evil twin re-encrypt the message with the key it shares with the victim access point and sends it on to the AP. So without VPN, so that's why the evil twin will make your network insecure. But then with a VPN, then client can encrypt first with the VPN key. Client can encrypt again with the key it shares with the evil twin. Right? If I still connect to the evil twin, right? And then still when the evil twin decrypts with the key it shares with the client, and then the decrypted message is still a message that is encrypted with the VPN key. So in this case, the client actually encrypt the message two times, right? First with VPN, then with the key that is shared by the evil twin. So even though the evil twin can decrypt at the first level with the um, shared key, it cannot decrypt the second level with the that is encrypted with the VPN key. So in this case, the evil twin cannot read the original message. So that's why companies should use VPNs wherever clients and servers exchange sensitive communication wirelessly. So nowadays, many organizations will require VPN connection when you try to connect to a company's network outside the company's physical location. So next we'll talk about Wi-Fi wireless LAN management. So a lot of times we need to do good planning when we try to put our access points in our building. So this access point placement must be done carefully for good coverage and also to minimize interference between access points. So normally you should lay out roughly 10-meter overlapping circles on your blueprints, right? And then you adjust for obvious potential problems such as thick walls and also filing cabinets. So if you have a lot of thick walls, and you may need to have more access points. Again, like in a lot of offices, you have rooms, you have walls, and then you have a lot of other, it can be some tall cabinets and also thick doors. Then you need to be careful about this. And also the other issue is for like in multi-story buildings, you must also consider placements in 3 dimensions. So of course, like you should have wireless access point on every story instead of just on one floor, right? So channel assignment to access point positions are also important, as we mentioned earlier. We'll try to avoid overlapping channels. So the installation will actually be also important, because when you install access point, you also need to do site surveys to determine signal quality. You really have some signal testing software to see whether the signal is good after your installation, and then you may need to have adjustment um, based on your placement, right? And then sometimes you may need to have multiple access points even in the same location. So on a campus, you can also see sometimes in one classroom there are already 3 to 4 access points. So that is actually based on the number of people connecting, right? In the same room. Then if you just have one wireless access point, then the processing speed will be slower, and also the bandwidth is supposed to be lower with just one access point. So when you expect many people to be using the Wi-Fi in the same room, so you might have to increase the number of access points as well. Now, of course, in these cases, when the access points are close to each other, you also need to be very careful about the channels. Try to make sure they don't overlap too much. So, and also this is something that you need to keep doing constantly, because conditions change constantly, because you have different people, they may have different usage behavior, and also you may have different other different physical changes to the environment. So you need to, it's not like after you install it then you can use it forever. You need to do more site surveys, and sometimes listen to user feedback, and then you improve your access point placement. So this is the screenshot showing like some of the signal testing software, right? So, and then like for example, this one here you can see this one is basically trying to listen to different um access points and look at the signals. This one, the signal strength, so it is in decibels. So we'll talk more about the signals later, but you can see they are actually all in negative number. So actually a smaller negative number like -64 actually is a better signal than -87. So these are better signals. And then when you go to -87 or -90, then it actually is weak. But then you have -60, then it's actually quite good. This like -44, then this one is even better. And then you can have a heat map like this to look at the signal strength. And a lot of times people will be walking around with this kind of software, and then to capture the strength at different location. And then if you have time, like we can physically meet them, we can also test this in our tutorial. A lot of times your access points actually are installed in many different locations, right? So the manual labor to manage many access points actually can be very expensive. Like you have to physically go to each router or access point to do all the settings. Then that would be very time consuming and expensive. So automation is therefore needed. So access points, they are managed devices on your network. So they can send data to the administrator at the management console, and administrator can also send commands to the access points. So that's why a lot of times these access points are remotely managed, right, through your management console like this. So when you need to send commands, when you need to get the statuses, or when you need to install patches, actually you can do it remotely. So here are some of the desired network management functionality. So these access points should be able to notify the administrator of failures immediately. There should be continuous transmission quality monitoring, remote access point power adjustment. Also, the administrator should be able to push software updates to the access points and also work automatically wherever possible. So also you should notify administrator of row access points or evil access points, and also notify the administrator of access points that have improperly configured security and or some other unusual activities. So and then it should again be able to do all this as automatically as possible. So next we'll talk about how we measure wireless signal strength using decibels. So strength of wireless signal is measured in this dBm. So what is it, right? So we'll first look at how power radios, how power ratios are measured. So power ratios can be given as simple ratios, like your initial power can be 30 milliwatts, final power is 10 milliwatts, right? That's your power of your electromagnetic wave. Then the power ratio of the final to initial is 1/3. So powers are often reported in decibels instead of milliwatts. So decibel is actually calculated by 10 times log base 10 P2 divided by P1, where P2 is your final power and P1 is the initial power. So in this case, says the initial power is 30, the final is 10, then the power ratio from the final to initial is 1/3. Right, so the decibel is calculated as 10 times log base 10, 1/3. Then in this case, this will give you minus 4.77. So somehow like people likes to represent decibel power in decibel because of the log scale. So just some example. So for example, example one, if say initial power is 40, final power is 10, and then P2 divided by P1, then is 0.25, and then if you take log is minus 0.6, and then multiply by 10, then is minus 6.02, right? So that's why is the minus 6.02 decibel for this one. And then example two, again, like initial is 10, suppose it becomes bigger, you amplify it so it becomes 30, so the power ratio is 3, and then you take log is 0.47, and then so it's actually 4.77 decibel. So when you have attenuation, then you have negative decibel values. When you have amplification, then you have possible decibel values. So each doubling means an increase of approximately 3 decibels, because when you take log 2, that is around 0.3, that is multiplied by 10, that is around 3 decibels. So each halving, on the other hand, would mean a decrease of approximately 3 decibel. So that means 3 decibel is a power ratio of 2, so we double it, right? And then 4 is 6 decibels, 8 times is 9 decibels. Now, of course, 16, then it will be 12. 32, then it will be 15 decibels. And then when it is half, then it's minus 3, then it's 1/4 minus 6, 1/8, then it's minus 9. So when we are doing this, we are converting the power ratio to the log scale. So of course, each increase by 10 times means an increase of 10 decibels, because log 10 base 10 is 1, right? When you multiply by 10, then it's 10 decibel. Log 100 base 10 is 2, multiply by 10, then it's 20. And this will be 30, 40, and 50. And this is minus 10, minus 20, and minus 30. So in dBm calculations, so what we do is P1 is always 1 milliwatt. So we use 1 milliwatt as the base, and then we look at your final signal and then see whether how it compares with 1 milliwatt. So when you do this, then it's called the dBm calculation. So it's not dB, it's dBm here. So this actually allows you to talk about the power of a radio in terms that allow comparisons of the power of different radios. And so if your transceiver power is 4 milliwatt, 4 milliwatt, then you compare it with 1 milliwatt, right? So it actually increased by 4 times. So we call it 6 dBm. Then if it's 10 milliwatt, then it's 10 dBm. 10 watt, 10 watt actually is 10,000 milliwatt. 10,000 milliwatt, then you take log 10, then you have 4 multiplied by 10, then in this case 40 dBm. Then if it's 0.5 milliwatt, that is minus 3 dBm. Right, so you just take your initial power always as 1 milliwatt as the base, and then you can do the calculation. So just some quick questions. Estimate without using Excel or calculator, what is the dBm value for radio operating at the following? So if it's 2 milliwatt, then 2 milliwatt divided by 1 milliwatt, right? So the ratio is 2, and then you take log, that is around 0.3. Then as we said, this one is around 3 dBm, right? 60 milliwatt, right? Remember earlier we said like every doubling is around 3. So you double how many times? 4 times, right? 2, 4, 8, 16, 4 times. So this one would be 4 times 3 dBm, so it will be 12 dBm. This one 1 watt, so it's 1000 milliwatt, and that would be, it will take log, then it will be 3, right? So multiply by 10, then it will be 30 dBm. And this one 0.1 watt, 0.1 watt, actually that's 100 milliwatt. That would be 20 dBm, right? Because you take log, there will be 2, then you multiply by 10, so it's 20. So in this case, it will be 20 dBm. So what is a good Wi-Fi signal? So now we know dBm, right? So normally dBm is used for this Wi-Fi signal measurement, just like the software screen that we looked at previously. So normally when you have around like minus 40, 50 dBm is already very good, like it's excellent signal. Like minus 30 dBm is supposed to be perfect signal, but normally that won't happen if you are very close to the access point, right? But if you have minus 40, 50, that is already excellent signal. That will be normally the case as well. See your Wi-Fi bar is all full, right? And then minus 60 dBm is still very good, reliable signal. And then people kind of say minus 67 is the minimum for voice and non-high definition video, right? So it will be kind of the minimum that you should use. Then of course, like if you have minus 70, minus 80, you can still use. But of course, when you have minus 80, then it will be kind of unstable already. Whereas minus 90, then you may still be able to access, but normally the connection is supposed to be quite bad, right? So normally, like if, I think again, normally when you have your software, then you can try to measure the signal. Right? You can also install this kind of Wi-Fi signal strength testing software easily on your mobile phone or on your computer. Right? Just go to the Google Store or your Apple Store and then download some app, and then they will be able to measure your Wi-Fi signal. Then you can try to walk around in your home and or walk around on campus and then see all this by yourself, right? And then now you know like what the dBm means. Actually, again, the smaller number like minus 40, minus 50 means a good connection, whereas if you are minus 80, minus 90, then that's actually bad connection. Now we'll switch to another very popular wireless technology, Bluetooth. So Bluetooth was created for relatively low speed transmission over small distances. So very small distances. So it's kind of like cable replacement technology for devices around your body or desk, because there have been many wires around the desk, right? Like for your mouse, for your keyboard, for your headphone, for your microphone. Then it's kind of like a technology to replace this kind of wire for very small distances. So it's not really fully like wireless LAN technology like Wi-Fi. So they don't replace each other, but they actually can work together. So classic Bluetooth actually gives only about 3 megabit per second, but gives a longer battery life. So there is a Bluetooth special interest group, Bluetooth SIG, to take care of the management and the new standards for Bluetooth. So there are different modes of operation for Bluetooth. So there's the classic Bluetooth and the high-speed Bluetooth. So the classic Bluetooth is running at a decent speed, like 3 megabit per second, as we said, but at low power. So it does not use a lot of power. That means it can have longer battery life. So the expected duty cycle usually it can be from low to high. Power required, as we said, low. Maximum distance is around 10 meters. So for high-speed Bluetooth, then high-speed transfer is available. So of course it can go for longer distance as well because of the higher power use. It can go actually up to 24 megabit per second, and the expected duty cycle is low, so you should only use it occasionally, otherwise you will be using up the battery very quickly. The power required is high and the maximum distance is 30 meters. So all Bluetooth connections are one-to-one connections. So for example, you have the so-called master-slave connection, like your mobile phone is sending something for the printer to print. Then in this case, the phone is the master and then the printer is a slave. And the master and his slave is called collectively a piconet. So that's kind of a name for that. And the master may have up to 7 slaves. So a piconet may have up to 8 devices together. One master and 7 slaves. So in this case, your mobile phone is the master. It can also have another slave, which is the headset. So a device, in this case, the desktop here, can be simultaneously a master and a slave. So it's a master for the keyboard and the mouse, but then at the same time, it can also be a slave for the mobile phone. Maybe the mobile phone want to transfer some file to the desktop, share some file, running synchronization. In that case, the desktop is the slave in this piconet, but there is a master for this one. So there are also different Bluetooth profiles. Each profile actually specifies how devices should work together for that particular application. Because when you have different applications, you might have different requirements. Right. So in this diagram, actually we are showing like for the desktop to the mobile phone, then there is a synchronization profile. It's for you to synchronize the files on 2 devices. And then for printing, then there is a basic printing profile, BPP. And then for example, for this headset, then there's also a headset profile. So we will take care of how to answer a call, how to hang up, adjust volume, and so on. So there are different profiles for the different applications. And just a reminder, as we said before, all connections are one-to-one connections. So we'll briefly talk about a few profiles here. So for example, the headset profile HSP. So it's really for using a mobile phone through a headset. So there are features that usually accessed through manual controls. Then you can actually do it through Bluetooth. So what happens when the phone rings, how to answer a call, how to hang up, how to adjust volume. Then all these are specified in this profile. And there is a very similar profile, which is the hands-free profile. It's kind of for using a mobile phone when you are driving. So the features accessed through voice commands. So instead of like pressing, for example, on the phone, that you have a lot of voice commands that can be handled by the mobile phone. Right? So and also then the headset profile will contain all those voice commands, how to understand that, and also you have like some other hands-free operation like last number redial, call waiting, voice dialing, and so on. And the basic printing profile specifies how to print to any BPP printer without having to load a printer driver. So a lot of times when you need to print something to a printer, you need to have the specific driver for that printer. But then for BPP, then you do not need to load the driver. And the synchronization profile is, as you can tell from the name, is for synchronizing information with a desktop computer, like with a wireless device. So all these profiles actually specify the features and the requirements used for each of the specific applications. So there's also this human interface device profile, which is for the Bluetooth mouse or mice, right? The plural form of mouse, right? And keyboards and so on. And there is also Bluetooth Smart that permits devices with the full operating system to interact. So this is very important because when we are talking about Internet of Things, that many things may have the Bluetooth capability, but it actually does not have the full operating systems. So for this kind of objects, that Bluetooth Smart will be very useful. So now we talk about some of the other local wireless technologies like NFC and also some other issues related to Wi-Fi. So NFC, which stands for near field communication, is actually for very small distances and low speed. So it's just up to 4 cm, which is about 2 inches. So limited to 424 kilobit per second. So not a fast speed and not a long distance. So actually, the good thing is it's actually use very little battery power. So it's operate in the 13.56 kilohertz band. So so this band is dedicated for this use, and also because of the low frequency, actually is use low power consumption. So it's for this small frequency communication that we have been using a lot for, like smart card, and also when we use our phone for payment, right? The touchless payment using your phone. That one, these are based on NFC. Right, so the good thing is there's no need to make physical contact. For example, when you pay a bus fare, as we said, when you use your phone as a credit card, to tap on the reader, that actually you can use this. So usually you slap a wallet against the reader to be sure to get close enough. So you don't need to take it out and really wipe a card. Right? So that is making all these um mobile payment faster and more convenient. So here are some of the sample applications. So payment of bus fares, so already popular in some countries using NFC or RFID, and also unlocking car doors and also turning on the ignition. So again, many of the cars these days, you don't turn the key to turn on the engine anymore or to open the door anymore for the cars. Basically, you just press the button and they will send signals. And many of these are based on NFC. So you can also use that to build door entry control, just when you tap your smart card on the reader, right? And then you can also share electronic business cards and other files between mobile devices. Right? If you have some apps, then they can automatically exchange information when you can put the two phones close to each other. And also use a lot in mobile payment, and also use it for like loyalty card, and to store your loyalty points, in shops. And also you can use to store coupons, and all these are beginning to be more and more popular. So of course we said we have been using a lot of this RFID tags, which is again based on this NFC. So the goal is really to replace barcodes, because barcodes you have to scan them one by one, but NFC actually should be read automatically. So the tags are electronic but have no power source. Like for example in this diagram we have the airport luggage handling system. For example in the Hong Kong airport, then all these luggages actually will an RFID tag will be put on this luggage. The tag itself actually has no power source. But then the good thing is when it's scanned by a reader, it will use the power of a scan to generate a reply. So just like many of the smart card, like Octopus card in Hong Kong, the card itself does not have battery, right? No power source. But then when it is being scanned, then the um the card will receive some electromagnetic signal, right? And that one actually already has some power. And that little power then can be used by the card to generate a reply, and also to update the records, right? So it's um, very inexpensive compared to powered devices. So all those RFID tag can be very cheap. So it can only do a small amount, send a small amount of information, but it's good enough for many purposes. Of course, then one limitation is it cannot do encryption, because encryption will require more computation, more power. So with the limited power, it cannot do encryption. But as we said, it's already good enough for many applications, so it's getting more and more popular. So another technology is called Wi-Fi Direct. So in Wi-Fi Direct, then two wireless devices that are running AO 2.11 can communicate directly without using an access point. So theoretically, when you have these two devices at home, right, a tablet and a mobile phone, and they can share their information, they can share their files using Wi-Fi direct instead of going through the router. But of course, like if I want to send some files from my tablet to my phone, normally what would you do? Normally you may not bother going through this Wi-Fi direct, right? You may turn on the Bluetooth, or sometimes you may even email, right? I email this um file from the tablet to the phone, and then the phone will go to the email server to download it. Of course, a lot of people will do it. It seems more convenient, but of course, like theoretically, what you can also do is you can use Wi-Fi direct or just Bluetooth, and then you can share the files. So of course, in wireless technologies, like local wireless technologies, you also need to be careful about the security issues. Like there are threats like eavesdropping. People may be listening to your traffic. There could be data modification and also impersonation. People may pretend to be you. So there are many cases like this, like people trying to steal cars because they can copy your signals that you send through Bluetooth. Because when you are sending your Bluetooth signal to unlock a car, actually people nearby can also receive the signal and also copy that signal. I just need to listen to that frequency band. Right? I look at all the signals in that band, and then I can actually get that signal. Right? And then I just regenerate the signal later on. Then actually I can do a lot of things. So this kind of security issues also need to be considered when we are using or designing this kind of applications. And as you said, some of these devices or some of these technologies actually do not have cryptological security. It cannot do encryption because of various limitations, maybe because of speed, and as you said, maybe because of power, because like NFC for reading passive RFID tags, because the RFID tags does not have power source, so it cannot do encryption. So in these cases, they will have to rely on short transmission distances to avoid the eavesdroppers, because when you tap the um say for example tap the octopus card, then you need to go through a very short distance, right? Supposedly like other people cannot get very close to that distance to read your message. However, it is actually also possible for people who are using some directional antennas and also amplifiers to read your signals that are far longer than distances in standards. When they use these very well designed directional antennas, they can actually get the signal from a specific direction, and also they can amplify your signal. Right, so that's what we are saying. Like people could use this to steal the signal for your car, for your car key, and then they can steal your car later based on that message. And some of these technologies actually have reasonably good security, like Bluetooth. So when we use this kind of emerging wireless technologies, we need to be careful. Like Bluetooth actually is quite good, but it's still not as strong as AO2.11i security. So when you, for example, transfer files on Bluetooth, then you need to be careful, right? But of course, we are not going into details here, but of course, like Bluetooth is still less secure than AO2.11i. Yeah, so we still need to be more careful when we are using this kind of applications. Like someone might try to remotely control your Bluetooth devices if you don't have a good security setting. So we also need to be very careful not to lose our mobile devices. So I know probably some of you might already have the experience of losing your mobile phone. And you know actually the consequences can be very bad, right? You are losing maybe a lot of your files, you are losing your photos and so on. And then if people try to use your phone to log into some of the apps that you are using, using log into your Facebook or your social media accounts, then they might be or like Gmail, then they might be able to read your Gmail and things like that, right? So although you say you might have locked your phone, right, but people may be able to unlock it using a lot of like breaking technologies. Then So when you are losing your device, again, it's a lot of problems that you need to handle. And it will be even worse if you are using your device for work, like because in this age of what we call bring your own device, BYOD, to work, this is actually a serious problem. A lot of people are using their laptop to connect to company resources, right? And also having a lot of these company files on their laptop or on their mobile phone. Then and also many of these devices are provided by short pins. Like you might not have very complicated password on your phone. So then as you said, it's relatively easy to break. So again, when we are using wireless technologies, we always need to be very careful with the physical control or physical protection of your device. Otherwise, again, you may get into a lot of troubles. So in general, new security technologies take some time to mature. So when it's first rolled out, normally the technology may not be very secure. But for example, like Wi-Fi, so it has been around for more than 20 years now, so it has become much more secure and mature, right? So the security can be trusted. But then again, for newer technologies like Bluetooth or NFC, then normally during the period before maturity, these technologies may have vulnerabilities that must be fixed quickly. Then user companies must master security for each new technology they use. So that's why if in the future if you are working like for company that are related to this kind of wireless security or wireless devices or wireless technologies, then we need to be very careful about the security of any new technologies that we are using. Actually, it's not only applied to networking, like it actually applies to many things. Like when you build an app, when you use particular software, when you use some particular services, and so on. So we always need to be very careful and vigilant about the security issues. So that's the end of this chapter. See you next time.